Okay, so we're going to continue on with our chapter, our section on energy. And so we talked about what is energy, we talked about kinetic energy, we talked about potential energy, and so now we're going to talk about the units of energy. And so if you remember when we did our SI units little table, we said what the SI unit was for energy, and we said it was the joule. So now most of our units actually have a definition. So think about, we had a definition for temperature and for volume, and we had one for your energy in general, but we also have one for joule, like how exactly was that measured? So a joule is the amount of energy needed to move a 2 kilogram mass a distance of 1 meter. Okay? Now, you might be asking yourself, well, that seems really, really precise. Like, how did they get that? So remember we said that energy was applying a force and it has to go across a distance. And so if I'm applying a force, the mass of that object is going to make a difference. If it's really heavy, I might not be able to push it, etc. If it's not as heavy, it's easier. And then I've got to apply it against a distance. So then the unit is a joule, but it also has subunits. So the subunits is a Newton meter. Newton is the energy, is the unit for force. So how much force does something have? And then applied across a distance. So this kind of fits our definition. A force applied across a distance. But a Newton can actually be broken down. So a Newton is also a kilogram times a meter per second squared. Okay? So this is the subunits of a Newton. So a Newton is a kilogram times a meter per second squared. So if I took this, plugged it into here, that's where I get my kilogram times my meter squared, because you have a meter here and a meter here, and then you get seconds on the bottom. Okay? Now, this might seem really funky, and how do you get this? So the way we get this is from our kinetic energy equation. So let me give you that. Kinetic energy, Ke, is equal to 1/2 times the mass times the velocity squared. So 1/2 mv squared. So m is the mass, v is the velocity. So let's say I want to plug in this information. So to get the units. So 1/2, the mass was a 2 kilogram mass. And I want to apply it across the distance 1 meter. And I'm just going to say it's some speed. We'll just say 1 meter per second squared. So let's just work out the units. I'm not really worried about what my number is as to how much energy it is. I just want the units. Okay? So these cancel. You have a kilogram. My meter is going to become squared. And my seconds are going to become squared. So you get a kilogram meter squared per second squared. That's what a joule is. That's where we get the joule. So a joule is a kilogram meter squared per second squared. That's what this is, and that's equivalent to a joule because this represents energy. Okay? So this is where they get the subunits. But this is kind of clunky and a lot to write, and so instead of doing that, that's why they combined it all into a new unit called a joule. Okay? The magnitude of a joule is so small that we're often going to express it in the amounts of energy in a bigger one, and so this is usually why we use kilojoules. So remember, kilo is 10 to the third. We're going to review our prefixes, that prefixes chart in a few more lectures. So kilojoule, kilo, so 1 kilojoule is going to be 1,000 joules. And so instead of saying joules, we usually are going to write it in kilojoules. Okay? Let's look at an example. So this problem says calculate the kinetic energy of a 6.649 times 10 to the negative 27 kilogram helium atom moving at a speed of 125 meters per second. So we have a problem. The first thing I want you to do is say, well, what am I looking for? So it says calculate the kinetic energy. So I'm looking for the kinetic energy. And since it's in energy, I know what the unit should be in. It should be in joules. what did they give me? So they told me that there is this guy. This is a mass unit, so I know the mass of my helium atom. And that atom is moving at a certain speed. So speed, in our case, it's going to be velocity, is our symbol, our V for velocity. So I'm trying to find the kinetic energy. I have the mass and the velocity. So if I'm trying to find kinetic energy, the only way I can find that is the kinetic energy equation. So I write that down. Kinetic energy is equal to 1/2 mv squared. Now, when I plug in my mass, we showed earlier the mass needs to be a kilogram for the units to work out, and the speed needs to be in meters per second. So here, my mass is in a kilogram, and my speed or velocity is in meters per second. So my units are good. I don't need to convert them before I plug it in. So all I have to do is take these guys and plug it in. So kinetic energy is equal to 1/2 times the mass times my velocity squared. So if I want to work out the math, you can multiply. You want to do your 125 squared first. So you want to get all of your exponents going. So if I multiply that, I get 15,625 meters squared per second squared. Then I can multiply all this out. And when I multiply it all out, and remember the units, because if I square the number, I also square the number and the units. So then when I multiply this all out, I get 5.19 times 10 to the negative 23, my kilograms, and then my meters squared per second squared. But then we say, okay, well, I wanted it in joules. So that's when we have to go back and remember that a joule is a kilogram meter squared per second squared. So this is the same thing as saying 5.19 times 10 to the negative 23 joules. Okay? So these problems, pretty much all you have to do is know the equation and then just plug everything into the equation. So I plug everything into the equation, and then at the end, you have to know that a kilogram meter squared per second squared is the same thing as a joule. Okay? So that is the last part of our energy. The next section we're going to move into is dimensional analysis, and it's our last section. And so this section is just pretty much doing a bunch of conversions. So on the next video, we'll start with that.